Today I'm going to show you how to solve for this integration, sine x over the square root of 1 plus cosine 2x dx. There will be some questions by students. Should I use U substitution or should I use some trigonometry identity to reduce this integration to something simpler? So U substitution doesn't work here. If you look at this denominator and we compare it with the numerator, we ask ourselves, can I differentiate something in the denominator and get something in the numerator? The answer is no, because in the denominator, we have cosine 2x over here, and no matter how we differentiate it, we'll never get sine x because the angle is different. So one thing to know is that if the angle is different, we should not be using U substitution to solve for this. Let's try another method, which is using trigonometry identity to solve for this integration. One trigonometry identity that we have learned before is with regards to cosine 2x. Usually we reduce the power, but there is a square root over here. So we can increase the power and take away the square root. So that's the trick over here. So in our formula sheet, we have cosine 2x is equals to 2 cosine square x minus 1. So let's try to replace cosine 2x with this term and see if we can do any cancellation. Let's copy the integration over. We get sine x over 1 plus 2 cosine square x minus 1. And don't forget the dx. And right now we notice that there's something that we can cancel. We can cancel off the 1 here and the negative 1 over here. So right now we are left with sine x over the square root of 2 cosine square x dx. Now 1 over square root 2, this is a constant. We can bring it outside. So let's bring the constant outside. 1 over square root 2. Now we are left with the square root of cosine square x in the denominator. We can remove the square root right now. So right now we are just left with 1 over square root 2. And we just need to integrate sine x over cosine x dx. Now sine x over cosine x, again, we try to simplify things by using trigonometry identity again. Sine x over cosine x is just tangent x. We'll copy this thing over again, and then we'll change the integration to tangent x and with respect to dx. Now the only task that we need to do is to integrate tangent x. How to integrate tangent x? We'll follow what is inside our formula sheet again. For the constant term, we'll copy over. And the answer will have a negative sign. We'll add a negative sign over here. And it will be ln cosine x. And remember to plus c. So that's the solution for this integration. So there's some key takeaways from this video. First key takeaway is check whether we can use the U substitution or not. If we cannot use U substitution, then we'll try to reduce it using trigonometry identity. Whether to increase the power or not depends on the square root that we can find in the denominator. If there's a square root in the denominator, we can remove the square root by trying to find if I can square any trigonometry terms so that the square root can be removed. So using this method can help us to solve for this integration.